Hey champs of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with their detailed PDF solutions. And you must download our app. The link is available in the description box for better preparation of your exam. So today, student, we will be solving JEE 2024 first Fab shift first paper. Okay. In this particular video, I'll be solving the physics part of the paper. So here we go. The question number 31. Okay. With rise in temperature, the Young's modulus of elasticity. So this question is from the chapter of properties of solid and liquid. So we have to find the correct answer from these four options. Okay. So first of all, we should know what is the effect of the Young's modulus elasticity with the temperature. Okay. So let us say Young's modulus of elasticity is the measure of the elasticity of the material, okay? And Young's modulus is given as Y is equals to F into L over A into delta L, where F is what? F is the stress, L is the original length of the wire, A is the area of cross section, and delta is the change in the length of the wire due to applied stress. Okay. Now the Young's modulus of elasticity is inversely proportional to the length of the wire. From this relation, we see that it is inversely proportional to length of the wire, and this length of the wire can be written as delta L is equals to L alpha delta T. Okay, where L is the original length, delta L is the change in the length of the wire, and alpha is the coefficient of linear expansion. It is the coefficient of linear expansion. Okay, and delta T is the change in the temperature. So we see that this length is directly proportional to what? Temperature. So if the temperature increases, the length also increases. And since Y is inversely proportional to L, so if L increases, then Young's modulus decreases. So it means with the rise in temperature, the Young's modulus decreases. So the correct answer is option B. Okay. Now next question 32. If r is the radius of the earth and acceleration due to gravity on the surface of the earth is given as g equals to pi square meter per second square, then the length of the second pendulum at the height h equals to 2r from the surface of the earth will be. So student, this question is from the chapter of gravitation. Okay. Let us say this is earth and its radius is capital R. Okay. Now we know that at the surface of the earth, the gravity G is given as Gm over R square. Okay. And if we considered some planet or something at a distance, at a height h from the surface of the earth, then the gravity formula becomes Gm over R plus h square. Okay. Now according to this question, this h is equals to what? 2r. Okay, so this g dash, let us say it is g dash, it is equals to gm over r plus 2r whole square. So it will become gm over 3r whole square. Okay, so it will be equals to g dash will be equals to 1 over 9 into gm over r square. So it will be equals to 1 over 9, and gm over r square is what? G naught. Gravity at the surface of the earth. So g dash will be equals to 1 over 9 into g naught. Okay. And so the time formula is equals to 2 pi under root L over G. We have to find this length of the second pendulum, and the time for the seconds pendulum is always 2 second. Okay, so now putting the value, so 2 second is equals to 2 pi under root L over G dash. G dash is what? 1 over 9 into G naught. So it will be equals to 1 over 9 into G naught. Okay, so 2 cancel. So we get squaring both sides, we get 1 equals to pi square into G into L over, sorry, this is 9, not G, into G naught. Okay, and G naught is given as pi square meter per second square. So it will be 1 equals to pi square into 9 into L over pi square. This pi square cancels. So L will be equals to 1 over 9 meter. This is our final answer. So the correct option is option B, that is 1 over 9 meter. Now next question 33. In the given circuit, if the power rating of Zener diode is 10 milliwatt, the value of series resistance Rs to regulate the input regulator supply is. We have to find the value of series resistance Rs. Okay. So this question is from the chapter of electronic devices. Now, as we see in this circuit, this is breakdown voltage given as Vz equals to 5 volt. This is load resistance RL. This is supply resistance RS. And this is supply voltage Vs. Okay. So, first of all, we will find the potential difference across RS. So, potential difference across RS will be, since V equals to IR from Ohm's law. So, if we want to find the potential difference, okay. So this potential difference will be equals to this 8 minus 5 across RS na. Potential difference will be this supply voltage minus this Zener voltage. So V1 will be equals to 8 minus 5. It will be equals to 3 volt. Okay. Now the current through the load resistor. Okay. Now current through the load resistor will be equals to IR. So I equals to V over R. Since V breakdown voltage is 5 volt, so here also voltage will be 5 volt. So it will be equals to 5 over R is given as 1 kilo ohm. 1 kilo ohm means 1 into 10 to the power 3 ohm means 5 milliampere. Okay. This is the current across the load resistor RL. Now the maximum current that is passing through Zener diode. The maximum current that is passing through Zener diode will be IZ maximum. It will be equals to, using V equals to IR, I equals to V over R. Okay. So I will be 10 over 5. IZ maximum will be 10 over 5. So it will be equals to 2 milliampere. Okay. And minimum current will be minimum current the minimum current will be 0. Okay. For any Zener diode, the maximum current will be found by using Ohm's law, and the minimum current will be found as 0. Okay. Now is maximum means the current through the supply voltage. The maximum current will be equals to this 5 current plus 2 equals to 7 milliampere. And so therefore RS minimum will become V1 over I maximum. So when the current will be maximum, so RS will have its minimum value, and V1 is 3 and I maximum is 7. So it will be equals to 3 by 7 kilo ohm. Similarly, in the same manner, IS minimum will be equals to 5 plus this minimum current 0. So it will be equals to 5 milliampere. So therefore, Rs maximum will be when current will be minimum, means divided by Is minimum. So it will become 3 over 5 kilo ohm. Okay. So we get the value of Rs, that is, it is between 3 by 7 kilo ohm to 3 by 5 kilo ohm. Okay. So from this answer, we see that uh, none of the options matches with this. So the correct answer is option E, none of the above. Now next question. The reading in the ideal voltmeter V shown in the given circuit diagram. Okay, we have to find the reading of the ideal voltmeter V. Okay, so this question is from the chapter of current electricity. Current electricity. Okay, at first we will find the value of the current that is flowing in this circuit. Now using Ohm's law, we know that V equals to IR. So current I will be equals to V over R. Total V voltage in the circuit will be 5. It means 1, 2, 3, 4, 5, 6, 7, 8. Means 8 into 5 over resistors. 1, 2, 3, 4, 5, 6, 7, 8. Means 8 into 0.2. So it will be equals to 5 over 0.2. It means 25. So the current will be 25 ampere in the circuit. Okay. Now we have to find the reading of the voltmeter V. Now using Kirchhoff's voltage law, KVL. Kirchhoff's voltage law. We write V voltage equals to E minus I into R by using Kirchhoff's law. So E is what? 5 volt minus I is what? 25 and R. In this whole circuit, the E is 5 and resistance is 0.2. So we get 5 minus 25 into R. R is what? 0.2. So we get 5 minus 5. So it will be equals to 0. So the correct answer is option C, 0 volt. Now next question 35. Two ideal capacitors have same capacitance C. One of them is charged to the potential V and the other to the potential 2V. The negative ends of both are connected together. When the positive ends are also joined together, the decrease in the energy. Okay, we have to find the decrease in energy of the combined system. So this question is from the chapter of electrostatics. Now, according to this question, let us say there are two capacitors having capacitance C, what is charged to voltage V, and another capacitor is charged to voltage 2V. Okay, this is V, this is 2V. So when these two are connected, when the negative end of both the are connected, so in whole system the voltage V is given as, since we know that Q equals to C into V, so V will be equals to Q by C. So Q net charge in both the combined capacitors over C, capacitance of the net, means combined both, when both the capacitors are combined, then their net capacitance. Okay, so Q will be equals to, Q is what? C into V. So for this Q will be C into V, and for this Q will be C into 2V over net capacitance C 2V, sorry, 2C. Okay, so this VC will be equals to CV plus 2CV over 2C. It will be equals to 3CV over 2C. This CC cancels, so we get 3 by 2V. Okay, now loss of energy. Loss of energy will be equals to Now the formula for energy is what? E is equals to half CV square. Okay, so for first capacitor, energy is half CV square for first capacitor. For second capacitor, it is half into C and V is what? 2V square minus the combination of both, that is half into capacitance is 2C into voltage. First voltage is V, the first one is V and the second one is 2V. It means 1 over V plus 1 over 2V. So it will be equals to 2V, 2 plus 1 means 3 by 2V. So it will be equals to 3 by 2V whole square. Okay. So solving it, we get 1 by 2 CV square plus 1 by 2 into C into 4V square minus C into 9V square over 4. And solving it, we get 2 2s are 4. So we get half CV square plus 2CV square minus 9 by 4 CV square. Taking CV square common, CV square, so we get 1 by 2 plus 2 minus 9 by 4. So solving it, we get CV square 4, 2 plus 8 minus 9. It will be equals to 10 minus 9 means 1 by 4 CV square. So the correct answer is 1 by 4 CV square. So the correct option is option A. Now next question 36. 2 moles of a monoatomic gas is mixed with 6 moles of a diatomic gas. The molar specific heat of the mixture at a constant volume is. So this question is from the chapter of kinetic theory of gases. Now, according to this question, we have to find the molar specific heat of the mixture at constant volume, means CV is equals to N1 into CV1 plus N2 into CV2 over N1 plus N2. And we know that there are 2 moles of monoatomic gas, means N1 means 2 and CV1 means for monoatomic gas it is equals to 3 by 2 R. Okay, and for diatomic gas N2 is equals to given as 6 and CV2 will be equals to 5 by 2 R, since CV formula is what? F by 2 into R, and for monoatomic F equals to 3, for diatomic F equals to 5, and for triatomic F equals to 6. So here we write 3 by 2 R, and for diatomic we write 5 by 2 R. So CV will be equals to 2 into 3 by 2 R plus 6 into 5 by 2 R over 2 plus 6. Now solving it, we get this 2 cancels, 2 3 the 6. So 3R plus 15R over 8. So we get 6 7 8. Okay, so we get 15 16 17 18 R over 8. So we get 2 9s are 18, 2 4s are 8. So CV will be equals to 9 over 4 R. So this is our final answer, 9 over 4 R. So the correct option is option A. Now next question 37. A ball of mass 0.5 kg is attached to a string of length 50 centimeter. Okay, it is attached to the string of a length of mass 0.5 kg and L is 50 centimeter. The ball is rotated on a horizontal circular path. Okay, about its vertical axis. Acha. The maximum tension that the string can bear is 400 Newton. Tension is given as 400 Newton. The maximum possible value of angular velocity. Okay, so this question is from the chapter of properties of solids and liquid. We have to find the angular velocity. So we know that tension is equals to mass into angular velocity square into L. Okay. So L is the length, this length. Okay. Or we can write T is equals to m omega square into R, where R we considered R here as length. So tension is given as 400, mass is given as 0.5 kg. We have to find this omega, and length is given 50 centimeter, means 0.5 meter. So solving it, we get omega square equals to 400 over 0.5 into 0.5. So it will be equals to 10 to the power 2. So it will be equals to 4 into 10 to the power 4 over 5 into 5, 25. Now solving it, we get omega equals to 40 radian per second. So the correct option is option B. Now next question 38. A parallel plate capacitor has a capacitance C equals to 200 picofarad. It is connected to 230 volt AC supply with an angular frequency 300 radian per second. The RMS value of conduction current in the circuit and displacement current in the capacitor respectively. Okay. So this question is from the chapter of electrostatics. Since current I is equals to voltage over XC, this XC is equals to capacitive reactance. It is equals to 1 over omega C. Omega is given as 300 radian per second, and a capacitance is given as 200 picofarad, and V is given as 230 volt. So just put this value and we will get the conduction current in the circuit, that is I equals to 230 over 1 over omega C, means 300 into 200 picofarad, means 10 to the power minus 12. Okay. 1 picofarad equals to 10 to the power minus 12 farad. Okay. Now solving it, we get 23 into 3 into 2 into 10 to the power 1, 2, 3, 4, 2, 3, 4, 5 minus 12. So it will be equals to 3 3s are 9, 3 2s are 6 into 2 into 10 to the power minus 7. So it will be equals to 9 2s are 18, carry 1, 6 to 12, 113. 138 into 10 to the power minus 7. It means 13.8 into 10 to the power minus 6 means 13.8 microampere. So the correct answer is 13.8 microampere. Okay. So our correct answer is answer D. Now next question 39. The pressure and volume of an ideal gas are related as PV gamma equals to constant. The work done when the gas is taken from state A to state B. So this question is from the chapter of kinetic theory of gases. Okay. We are given PV gamma equals to K constant. Okay. This is the equation for an adiabatic process. Now, for PVX, let us say this is X equals to constant. If work is done, so work done formula in case of such type of equation where we are given with the value of gamma, the work done is given as nR delta T over 1 minus gamma. This is the formula for an adiabatic process when we are given PV gamma equals to constant. So using this gamma formula, work done is equals to nR delta T over 1 minus gamma. Now for an ideal gas, we know that EV equals to nRT. So in place of nRT, we write PV. Since there is change in the temperature, so we can write W is equals to P2V2 minus P1V1 over 1 minus gamma. And gamma is given as what? 3 by 2. So 3 by 2. So it will be equals to P2 V2 minus P1 V1 over minus 1 by 2. This, according to this minus sign, we can write W is equals to 2 into P1 V1 minus P2 V2. So our correct answer is option A, that is 2 into P1 V1 minus P2 V2. Now next question 40. A galvanometer has a resistance of 50 ohm and it allows maximum current of 5 milliampere. It can be converted to a voltmeter to measure up to 200 volt by connecting in series. Okay. Now this question is from the chapter of magnetic effects of current and magnetism. Now according to this question, let us say this is Ig. This is galvanometer G, resistance Rg, and this is resistance R. Okay. Now, according to question, it has a resistance of 50 ohm, means Rg is given as 50 ohm, and it allows a maximum current of 5 milliampere, means Ig is equals to 5 milliampere, means 5 into 10 to the power minus 3 ampere. It can be converted into voltmeter to measure up to 100 volt. Okay. So using the formula, R is equals to V over Ig minus Rg. So V is 100 volt over Ig is 5 into 10 to the power minus 3 and Rg is what? 50. Now solving it, we get 10 power 2 plus 3 over 5 minus this 50. So it will be equals to 10 to the power 5 over 250 over this 5. So solving it, we get, acha, if we solve it like this, instead of this, right, solve it, we get 20,000 minus 50. So it will be equals to 19,950 ohm. Okay. So the correct answer is R equals to 19,950 ohm. Option C is the correct answer. Now the next question is 41. The de Broglie wavelengths of a proton and alpha particle are lambda and 2 lambda respectively. The ratio of the velocities of proton and alpha particle will be. So this question is from the chapter of modern physics. Okay. In this question, we have to find the ratio of the velocities. Okay. From de Broglie hypothesis. From de Broglie hypothesis, we know that lambda is equals to h over p, where h is the Planck's constant and p is the momentum, and this momentum is equals to mass into velocity. So from here, velocity is equals to what? H over m into lambda. Okay. So h is constant. So only the variables are mass and wavelength. So velocity is inversely proportional to this mass and wavelength. Na? So Vp, velocity of proton, will be equals to 1 over mass of proton into wavelength of proton. And this velocity of alpha particle will be equals to mass of the alpha particle into wavelength of the alpha particle. So Vp over V alpha from equation 1 and equation 2, Vp over V alpha will be equals to what? M alpha over MP into lambda alpha over lambda p. Okay. Now putting the values, Vp over V alpha is equals to wavelength are lambda and 2 lambda respectively. Okay. So it will be equals to M alpha over MP into what proton is of lambda and alpha is of 2 lambda. Okay. So this lambda and lambda cancels, and we know that the mass of the alpha particle is 4 times the mass of the proton. So 4 into mp over mp into 2. This mp cancels. So we get the ratio of 4 Vp over V alpha is equals to 8. So the correct option is 8:1, means option D. Now next question 42. 10 divisions on the main scale of a vernier caliper coincide with 11 divisions on the vernier scale. If each division on the main scale is of 5 units, the least count of the instrument is. This question is from the chapter of units and measurement, and the same question has been asked in this year only, in I think January 29th shift paper. So these type of questions are being repeated. Okay, so according to this question, 10 main scale division is equals to 11 vernier scale division. Okay, it means one vernier scale division equals to what? 10 over 11 main scale division. So we have to find the what? Least count of the vernier caliper. Na? So least count, the formula for least count is what? 1 main scale division minus 1 vernier scale division. So it will be equals to 1 MSD minus 10 over 11 MSD. Okay, from equation 1. So it will be equals to 11 MSD minus 10 MSD means 1 MSD over 11. So least count is equals to 1 over 11 MSD. Okay, it means one main scale is 5 units. So it will be equals to 5 over 11. So our correct answer is option D. Now next question 43. In series LCR circuit, the capacitance is changed from C to 4C. Okay. To keep the resonance frequency unchanged, the new inductance should be. So this question is from the chapter of electromagnetic induction and alternating current, induction and alternating currents. Okay. According to this question, there is an LCR circuit. There is an LCR series circuit. Okay. It is connected to a voltage V, LCR, and the capacitance is changed from C to 4C. At first, the capacitance is C, then is changed to 4C to keep the resonance frequency unchanged. Okay. Now the new inductance should be. We know that the resonance frequency omega, it is equals to 1 over under root LC. This is the common formula for finding the resonance frequency. Okay. According to question, the resonance frequency C should be unchanged, means omega dash must be equals to omega. It means 1 over under root of L dash C dash must be equals to 1 over under root of LC. This under root squaring both side, we get L dash C dash, it will be equals to LC. Now C dash is what? 4C. So L dash into 4C equals to L into C. This C cancels. So we get L dash is equals to 1 by 4 L. Okay, now the question is saying that to keep the resonance frequency unchanged, now means there is no change in the frequency. So to keep it unchanged, the new inductance should be L dash should be 1 minus 1 by 4 of L, means the L dash should be 3L by 4. It must decreased by 3L by 4. The new inductance must decrease by 3L by 4 to make it as 1 by 4L, because at 1 by 4L the resonance frequency remains unchanged, so it must be reduced by 3 by 4L. Okay, now next question 44. The radius R, length L, and resistance R of a metal wire are measured in the laboratory. We have to find the percentage error in resistivity. Okay, so this question is from the units and measurements again. Now We know that the formula for resistivity R is related to radius R, resistance R equals to rho L over A. So rho will be equals to R A over L. Where A is the area, it is equals to pi into R square. So it will be equals to R into pi into R square over L. Now this pi is constant, and using error analysis, error analysis, we write delta rho over rho is equals to delta R over R plus 2 delta R over R plus delta L over L. Now putting the values, delta R over R. Delta R is what? 10 over R is 100. So 10 over 100 plus 2 into del R over R. 0.05 over 0.35. 0.05 over 0.35 plus delta L over L. 0.2 over 15. So it will be equals to 0.2 over 15. Now solving it, right? 1 over 10 plus 2 over 7 plus 1 over 75. Since we have to find the percentage error, so multiplying it with 100, we get 39.9%. This is our final answer. Okay. Now, next question, 45. The dimensional formula of an angular impulse is. So this question is again from the chapter of units and measurements. Now we know that angular impulse is equals to change in angular momentum. Means the formula for angular momentum is what? L equals to mvr. Okay. M, the dimension for mass is capital M. For velocity, V equals to LT minus 1. LT minus 1. And for R, it is L. So the dimension of angular impulse are M, L2, T minus 1. So the correct option is option D. So the next question is 46. A simple pendulum of length 1 meter has a wooden bob of mass 1 kg. It is struck by a bullet of mass 10 to the power minus 2 kg moving with a speed of 2 into 10 to the power 2 meter per second. The bullet gets embedded into the bob. The height to which the bob rises before swinging back is. Okay. So this question is from the chapter of oscillations and waves. So now, according to this question, there is a simple pendulum and its length is 1 meter. Okay, let us say its length is L equals to 1 meter and a wooden bob of mass 1 kg. Okay, this is a wooden bob. Let us say its mass is capital M. It is of 1 kg and it is struck by a bullet. Let us say a bullet is coming from this direction. This bullet gets embedded in this block of mass M equals to 1 kg. Okay, and this bullet is having a mass of 10 to the power minus 2 kg and it is moving with a speed of 2 into 10 to the power 2 meter per second. Then the bullets get embedded into this block of mass 1 kg. We have to find the height to which the bob rises before swinging back. Okay, we have to find the height. Okay, it rises before swinging back. Okay, so now in this question we will use the conservation of momentum. Conservation of momentum means the momentum before the bullet gets embedded into the mass, into the block, and after it's get embedded into the block, these two momentum must be same. So using conservation of momentum, P1 must be equals to P2. That is, initial momentum must be equals to final momentum. So initial momentum will be mass of the bullet into the speed with which it is moving towards the block, and it is equals to mass of the block plus mass of the bullet, since it is gets embedded into the block. Okay, and its velocity v. So its mass is what, 10 to the power minus 2 kg, into velocity is what, 2 into 10 to the power 2, equals to capital M. Capital M is of 1 kg plus small m is the mass of the bullet, and it is of 10 to the power minus 2 kg into this v. Since 10 to the power minus 2 is very small quantity, so we considered it as 1 only, 1 into v. So from this we write 2 equals to 1 into v, therefore v equals to 2 meter per second. So we get the velocity with which this block, after the bullet gets embedded inside the block, is moving with a velocity of 2 meter per second. Now we have to find the height. Okay, so using laws of motion, that is v square equals to u square plus 2as. Here the initial velocity is 0, since it is at first it starts from the rest na. So final velocity v square will be equals to 2 into acceleration, means gravity, into s. S is the height here. So we write h is equals to v square over 2g. So it will be equals to 4 over 2 into gravity. Gravity we will consider g as 10 meter per second square. So 10. 2 2s are 4. It will be equals to 2 over 10, that is 0.2 meter. So the height is 0.2 meter, means option B is correct. Now next question. 47. A particle moving in a circle of radius r with uniform speed takes time t to complete one revolution. Okay, if this particle is projected with the same speed at an angle theta to the horizontal, the maximum height attained by is equal to 4r. We have to find the angle of projection. So this question is from the chapter of kinematics. So according to question, the velocity v will be equals to what, 2 pi r over t. Okay, the velocity will be equals to 2 pi r over t, and we have to find the angle of projection. So for the angle of projection, we will use here the maximum height formula. Okay, so we know that for a projectile motion, the maximum height formula is always equals to h. It is equals to u square sine square theta over 2g. Okay, so we will write here height is given as 4r. So 4r will be equals to u square sine square theta over 2g, and u here is what, 2 pi r over t. Now putting this value of velocity here, so we get 4r is equals to 4 pi square r square sine square theta over t square into 2 into g. Okay, so we get sine square theta will be equals to this 4 cancels, r cancels. So we get sine theta is equals to t square into 2g over pi square into r. Okay, so theta will be equals to, so sine theta, first of all, sine theta will be equals to under root of 2g t square pi square r. So theta will be equals to sine inverse 2g t square over pi square r power 1 by 2. So our correct answer is option A, that is theta equals to sine inverse 2g t square pi square r power 1 by 2. Now next question 48. Consider a block and a trolley system as shown in the figure. If the coefficient of kinetic friction between the trolley and the surface is 0.04, the acceleration of the system in meter per square is. So this question is from the chapter of laws of motion. Now, according to the figure, there is a trolley, sorry, there is a block, and this block is moving of mass 20 kg, and it is moving through this trolley, and now it goes down in the downward direction. This block is of mass 6 kg, and the force acting in the downward direction is 60 Newton. Okay, first of all, we will find the force for this block of mass 20 kg. So here the force due to the friction will be equals to coefficient of friction into n. So it will be equals to n is what? Mass into gravity. So it will be mu mg. So it will be equals to mu. Mu is given as 0.04 into mass is given as 20 gram. 20 gram na. Okay. Sorry, mass is 20 kg, sorry, not gram. 0.04 into 20 into gravity g. Okay, so it will be equals to 8 Newton. So this frictional force will be equals to 8 Newton. Now we will use the formula force equals to mass into acceleration. Since we have to find the acceleration, A is equals to F over M. So force will be equals to this 60 Newton force acting in the downward direction minus this 8 Newton force. Okay, so 60 minus 8 over mass. Mass is what? 20 plus this 6, 26. So it will be equals to 2 meter per second square. So our answer is option C. Now next question 49. The minimum energy required by a hydrogen atom in ground state to emit radiation in Balmer series nearly is. So this question is from the chapter of atomic and nuclei. Atomic and nuclei. Now it is asking about the Balmer series. Balmer series means this is Lyman series, n equals to 1. Balmer, n equals to 2. Paschen, n equals to 3. Bracket, n equals to 4. And P1. This is a spectrum, okay? Lyman, Balmer, Paschen, bracket, P1. It is asking the minimum energy required for a hydrogen atom in ground state to emit radiation in Balmer series. Okay. From the ground state to the Balmer series means the transition must be from n equals to 3 to n equals to 1. When this transition occurs, then we says that we can derive the expression for minimum energy that is required for a hydrogen atom in a ground state to emit radiation in the Balmer series. So the transition will be from n equals to 3 to n equals to 1. Now in the ground state, a hydrogen atom has the energy minus 13.6 over n square. For the ground state, n equals to 1. So it will be equals to minus 36 over 1 square equals to minus 13.6 electron volt. Now for n equals to 3. So E3 will, this is E1. E3 will be equals to minus 13.6 over n square means 3 square means 9. So it will be equals to 9, 1's the 9, 9 5's are 45. Okay, so it will be minus 1.5 electron volt for n equals to 3. Now the transition is from n equals to 3 to n equals to 1 means delta E will be equals to, subtracting this, minus 1.5 minus of 13.6. So it will be equals to minus 1.5 plus 13.6. It will be equals to approximately 12.1 electron volt. So energy will be equals to 12.1 electron volt. That is option D is correct. Now next question 50. A monochromatic light of wavelength 6000 angstrom is incident on a single slit of width 0.01 mm. If the diffraction pattern is formed at the focus of the convex lens of focal length 20 centimeter, we have to find the linear width of the central maximum. So this question is from the chapter of wave optics. So for the linear width of the central maximum, Okay, let us say this is the point source. This is a coherent source, means the light coming from this source will be the coherent light. And this is a monochromatic light, and this light source is wavelength is given as 6000 angstrom. Okay, it is incident on a single slit. Let us say it is incident on this slit, and wavefronts are coming from it, and on the screen it is forming a diffraction pattern. Okay, from this, on the screen it is forming a diffraction pattern. This is a screen, this will be the slit, and this is the distance between slit and the screen. And let us say uh, diffraction pattern is formed at the convex lens. Okay, so there is a direct formula for such type of question to find the linear width. That is, width will be equals to 2 into lambda into the focal length of the lens that we are using over the distance a, means slit width. Okay, so linear width will be equals to 2 into lambda. Wavelength is given as 6000 angstrom, means 6000 into 10 to the power minus 10 meter, into focal length is given as 20 centimeter, means 20 into 10 to the power minus 2 meter, over width of the slit. A is the width of the slit. Okay, so A is given as 0.01 mm, means 1 into 10 to the power minus 5 meter. So solving it, we get width equals to 2.4 into 10 to the power minus 2, means 24 mm. Okay, so our correct answer is option B, 24 mm. So now the next question is 51. A regular polygon of 6 sides is formed by bending a wire of length 4 pi meter. If an electric circuit current of 4 pi root 3 ampere is flowing through the sides of the polygon, the magnetic field at the center of the polygon would be x into 10 to the power minus 7 Tesla. We have to find the value of this x. So this question is from the chapter of magnetic effect of current and magnetism. Effect of current and magnetism. Okay, so we are asked in this question to find the magnetic field at the center of the polygon. Let us say this is a polygon. Okay, a polygon is having sides, 6 sides. So here n is equals to 6, and we have to find the magnetic field. Let us say this is point O at the point of this polygon. So if we find the magnetic field due to any of the one side and multiplying it with 6, we can get the magnetic field due to the whole polygon. Okay, let us say we will find the magnetic field due to this side. Okay, now let us draw this side as this is point O, this is side A. Okay, let us say the polygon having a side A. Okay, and according to question, a length of 4 meter is used by bending it the wire, and we have made the polygon. So the total length is what? 4 pi meter. So A will be equals to 4 pi by 6 meter, means the side of one of the side of the polygon is of 4 pi over 6 meter. Okay, now we have to find the magnetic field due to one side of this polygon, and to find the desired answer we will multiply it with 6. So this is a polygon, so all the angles will be of 60-degree, means it is an equilateral triangle. So equilateral triangle means all sides are equal, each of side A. Now, if we want to find the magnetic field at this point, so let us say the figure is like this. Okay, this is point O. This is of 60-degree, means this is of 30-degree, and this is also of 30-degree. This is of 60 and this is of 60. Okay, let us say we name it as AB. AB. Now the magnetic field at the point O will be, due to this single side AB, will be mu naught over 4 pi into current I flowing in this figure over R. R is this distance. Okay, this is distance R. R into sine alpha 1 plus sine alpha 2. this, let us say this is angle alpha 1 and this is angle alpha 2. So it will be equals to mu naught over 4 pi into I over R. Now we have to find this R. This is A, this is also A, and this is also A. Now using cos formula, cos is what? Cos theta equals to base over hypotenuse. So this is perpendicular, this is base, and this is hypotenuse. So base over hypotenuse means R over hypotenuse is what? A. A equals to cos theta means R is equals to A cos theta, and here theta is 30 degree. So R will be equals to A cos 30 degree. Okay. So we write in place of R A cos 30 degree, and sine alpha 1 means sine 30 plus sine 30. Now putting the values, 4 pi is what? Mu naught is what? 4 pi into 10 to the power minus 7 over 4 pi into I. Current is given as 4 pi root 3 ampere. 4 pi into root 3 ampere. Now 4 pi root 3 over A side is 4 pi by 6 into cos 30 into cos 30 means root 3 by 2 into sine 30 1 by 2 plus sine 30 1 by 2. Now solving this, we get 10 to the power minus 7 into root 3 over pi by 6 into root 3 by 2 into 1 by 2 plus 1 by 2. 2 by 2 means 1. So solving it, we get, and multiplying it with 6, because this is due to only one side. Na? We have to find due to the whole polygon. So multiplying it with side 6, the net magnetic field will be equals to 72 into 10 to the power minus 7 Tesla. And comparing it with given in the question, x into 10 to the power minus 7 Tesla. So here the value of x is 72. Okay. Here the value of x is 72. Now the next question is 52. A rectangular loop of sides 12 centimeter and 5 centimeter with its sides parallel to the x and y axis respectively moves with a velocity of 5 centimeter per second in positive x direction. Okay. And the variable magnetic field is in positive z direction. Okay. Means in outward direction. The field has a gradient of 10 to the power minus 3 Tesla per centimeter along the negative x direction, and it is decreasing with a time at a rate of 10 to the power minus 3 Tesla per second. We have to find the power dissipated by the loop. Okay, so this question is from the chapter of electromagnetic induction and alternating current. Electromagnetic induction and alternating currents. Okay, alternating current. Now in the question it is given that a rectangular loop of side 12 centimeter and 5 centimeter, they are along x and y axis respectively. Let us say this is length of 12 centimeter and breadth is of 5 centimeter, and they are along x and y axis. Let us say this is x axis, this is y axis. Okay, and this is moving with a velocity of 5 centimeter per second in the positive x direction, and the magnetic field is in positive z direction, means the magnetic field is in the outward direction. Okay, now the field has a gradient of 10 to the power minus 3 Tesla per centimeter. Gradient means del B over del X, means the change of magnetic field with respect to the length. It is given as 10 to the power minus 3 Tesla, means minus of 10 to the power minus 3 Tesla per centimeter, means 10 to the power minus 2 in terms of meters. So del B over del X will be equals to minus of 10 to the power minus 3 plus 2 equals to minus 10 to the power minus T1 Tesla per meter. Okay. per meter. Again, in the question is that the gradient is in the negative x direction. Thus we have used this negative sign now, and it is decreasing with the time at a rate of 10 to the power minus 3 Tesla per second. Okay, first of all, we are given with the gradient del B over del X equals to minus 10 to the power minus 1 Tesla. Okay, let us first find the magnetic value of this magnetic field. So del B over del X is what? Minus 10 to the power minus 1. So from integrating it from B naught to B dB, it will be equals to from 0 to X 10 to the power minus 1 dx, means when the value of X is 0, when the value of X is 0, at that time magnetic field is B naught, and when the value of this X is, let us say X, at that time the magnetic field is B. Okay, so for this, B minus B naught will be equals to minus into 10 to the power minus 1 X. So B will be equals to B naught minus X over 10. Okay, so B means in this direction. Okay, now the coordinates are here. The coordinates will be minus 12 comma 0. Here the coordinate will be minus 12 comma 5. Here the coordinates are 0 comma 0. Okay, and here the coordinate will be 12 comma 5. Okay, now we will find the motional EMF. Okay, now let us say this is point A, this is point B, this is C, and this is D. Okay, in point AB and CD, in point AB, motional EMF, let us say motional EMF in AB. In AB, the motional EMF will be, we know the formula for motional EMF is what? B V cross L, means BVL sine theta. Okay, so here the V is in this direction and magnetic field is in this direction. So both velocity and magnetic field are perpendicular to each other, means 90 degree, and sine 90 is what? 0. So motional EMF in AB will be 0. And similarly, the motional EMF in CD will be also 0, since this velocity is in this direction and magnetic field is in this direction. So the perpendicular means 90 degree. So in CD also the motional EMF will be 0. Okay. Now the motional EMF in BC, will be this BC. In this the motional EMF will be B naught. In BC the motional EMF will be B naught VL. Since we are seeing when the X is 0, the magnetic field is 0, means in BC, the motional EMF, we consider the magnetic field as B naught. So the motional EMF will be B naught VL. Okay. And now the motional EMF in AD. In AD, the motional EMF will be what? BVL, because in AD the magnetic field is B. So BVL. And here B is what? B naught minus X over 10. Na? So B naught minus X. X is here minus 12. Okay. B naught minus 12 over this 10 into L. Length. Length is given as 5 centimeter. Okay. So it will be equals to, okay, first of all, we will write it as V into L only. Okay. because it will be easy for us to solve these. So this is, let us say, E1, and this is, let us say, E2. Okay, this is equation 1, this is equation 2. And since it is in centimeter, na, minus 12 over 10 is in centimeter because the length are given in terms of centimeter. So multiply it with 10 to the power minus 2 to make in meter. So 12 into 10 to the power minus 2. Okay. So the net EMF equivalent will be equals to E2 minus E1. Okay, the net equivalent EMF will be E2 minus E1. So E2 minus E1 will be what? 12. This. It will become B naught plus 12 into 10 to the power minus 2 over 10 into VL. Over 10 means 10 to the power minus 3 into VL, and minus E1. E1 is B naught VL. So solving it, we get B naught VL minus B naught VL plus 12 into 10 to the power minus 3 into V. Velocity is 5 centimeter per second, means 5 into 10 to the power minus 2 meter per second, into length, means 5. And here in this case, this length is 5 centimeter, means 5 into 10 to the power minus 2 meter. So solving it, we get this B naught VL cancels out each other. So we get 300 into 10 to the power minus 7 volt. So here equivalent EMF will be 300 into 10 to the power minus 7 volt. Now, let us say this is equation 3. Now in question, it is given that the field as a gradient, and it is decreasing with a time at rate of 10 to the power minus 3 Tesla. Means we are given del B over del T, and it is decreasing with a rate of, decreasing mean minus sign, it means 10 to the power minus 3 Tesla. Okay. Also we know that EMF is equals to what? Del phi over del T. Okay. It is equals to phi. Phi is magnetic flux. Phi is equals to B dot A. Okay. Minus del phi over del T. Na? So it will be equals to minus A. And del B over del T is already in minus sign because it is in decreasing. Minus 10 to the power minus 3 Tesla. So minus minus will become plus. Del B over del T. And del B over del T is what? A into 10 to the power minus 3. And area will be length into breadth. Length is 12 and breadth is 5. Means 60 into 10 to the power minus 4, because both are given in terms of centimeter, into 10 to the power minus 3. So it will become 60 into 10 to the power minus 7 volt. So EMF will be 60 into 10 to the power minus 7 volt. Let us say this is equation 4. So net EMF will be equals to equation 3 plus equation 4. Equation 3 EMF is what? 300 into 10 to the power minus 7. 300 into 10 to the power minus 7 plus 60 into 10 to the power minus 7. It means 360 into 10 to the power minus 7 volt. Okay. And now we are asked to find what? Power dissipated by the loop. So power formula is what? V square over R, EMF over R, na? So power dissipated will be net EMF whole square over R. So net EMF whole square means 360 into 360 into 10 to the power minus 14 over R. R is given as what? R is 6 milliohm. So it will be equals to 6 into 10 to the power minus 3. So it will be equals to 6 are 36. So 60 into 360 into 10 to the power minus 14 plus 3. So it will become 6 is 36, 6 carry 3, 6 is the 18, 19, 20, 21 into 10 to the power minus 14 plus 3 plus 2. So it will be equals to 216 into 10 to the power 325 minus 9. So the correct answer is power equals to 216 into 10 to the power minus 19 watt. Okay. Okay, we have to find the answer in terms of minus 9. So we are correct. 216 into 10 to the power minus 9 watt. Okay. So the next question is 53. The distance between object and its 3 times magnified virtual image as produced by a convex lens is 20 centimeter. The focal length of the lens used is okay. So this question is from the chapter of optics. According to question, we are given a convex lens and the distance between object and its 3 times magnified virtual image. 3 times magnified virtual image means magnification is equals to V over U. Its value is given as 3. Means V is equals to 3U. Let us say this is equation 1 and the distance between object and image is 20 centimeter. Means let us say this is object O and its a virtual image is forming here in this at this point. Okay, I. So if this is the distance U and this is the distance V, so the distance between this object and the image, it is given as 20 centimeter. Means V minus U is given as 20 centimeter. Let us say this is equation 2. Okay, we have to find the focal length. So since V minus U equals to 20 centimeter and V is what? 3U. So 3U minus U equals to 20. 2U equals to 20. So U is 10 centimeter. Okay, this is 3. Now using focal length formula, 1 over V minus 1 over U equals to 1 over F for convex lens, and V image is forming in the left hand side. Due to sign convention, we will take V as negative, and object is also on the left hand side. So due to sign convention, it is also negative. It is equals to 1 over F. V is 3U and U is 10, means 1 over minus of 30 minus minus plus U is what? 10 equals to 1 over F. Now solving it, we get 30 minus 1 plus 3 equals to 1 over F. So F will be equals to 30 over 2. It means 15 centimeter. Means the focal length of the given convex lens is 15 centimeter. Now next question 54. Two identical charged pairs are suspended by a string of equal lengths. The string makes an angle theta with each other. When suspended in water, the angle remains the same. If the density of the material of this pair is 1.5 gram per cubic centimeter, the dielectric constant of the water will be. So this question is from the chapter of oscillations and waves. We are given with two identical charges pair and suspended by strings. Okay, let us say these are two charges pair and these are identical. Okay, and the angle between them is given as theta. So this angle will be theta by 2 and this is also theta by 2. Now when suspended in water, at first they are in air. So let us first consider the case of air. In case of air, this is tension force. Okay. In case of air, since these two pairs are identical, means they are having same mass and all. So this sphere is exerting an electrostatic force in this direction, Fe, and mg force in downward direction. Okay. Since this angle is theta by 2, if we extend it, okay, if we extend it, so this angle will be also theta by 2. So from this case, tan theta by 2, tan theta means perpendicular over base, tan theta by 2 will be Fe over mg. This electrostatic force due to this sphere acting on this sphere over downward gravitational force. Okay. So this tan theta by 2 will be equals to Fe electrostatic force means K into Q1 Q2 means Q square charge of both the spheres over this mass. We will write this mass as rho into V into gravity, and length. Length is also a factor, na? Fe electrostatic force is what? 1 over 4 pi epsilon naught Q square over R. So this R is what? Length. So for this sphere, the length will be equals to L sine theta by 2 in this direction. And for this, it is also L sine theta by 2. So for both the whole system, it will become 2L sine theta by 2. Okay, so it is R square means here we write 2L sine theta by 2 whole square. Okay, this is equation second. Now, according to question, this system is now suspended in water, and when it is suspended in water, this angle remains the same. Means this whole angle theta remains the same. There is no change in theta. So theta will be equals to theta dash when it is in air, and when it is in water, the angle doesn't change. So theta will be equals to theta dash. Now, if the density of the material of the sphere in water is given as this, sorry, in air is this, so we have to find the dielectric constant of the water, and density of water is given as this. Okay, we have to find the value of dielectric constant. So when we put this whole system, when it is suspended in water, let us consider second case as water. Then let us say this is the sphere, the tension force is acting in this direction, electrostatic force is acting in this direction, and in downward direction there is gravitational mg force. So when it is suspended in water, so a buoyancy force will act in upward direction. Okay, so for water, this tan theta by 2 will now become k into q square over this. There will be introduced a term that is dielectric constant, 2L sine theta by 2 whole square into mg. Mg means, sorry, into mg, but here buoyancy force is acting in this direction, upward direction, so it will be mg minus fb, buoyancy force, into this. Okay, now this tan theta by 2 will become k q square over epsilon, this dielectric constant, 2L sine theta by 2 whole square into rho into v, rho into v of when it is in air minus when it is in water into v into gravity. Okay, into g. Let us say this equation is equation 3. Okay, now from equation 3 and 2, dividing equation 3 and 2. Okay, dividing equation, let us say 2 by 3. So we get tan theta by 2 equals to k q square over 2L sine theta by 2 whole square into rho vg over what? This equation 3, that is tan theta by 2 equals to k q square over this dielectric constant into 2L sine theta by 2 whole square into rho v minus rho w into v into this gravity. Okay, so this k q square cancel, 2L sine theta by 2 whole square, 2L sine theta by 2 whole square cancel, tan theta by 2 cancel. So we get epsilon into rho v minus rho w, that is of water, into v into g. It is equals to rho v g. This g cancels. So epsilon rho minus rho w Taking V common equals to rho into V. This V cancel. So we get this dielectric constant is equals to rho over rho minus rho W. And for air, this rho is given as what? 1.5, and for water it is given as 1. So it will be equals to 1.5 over 1.5 minus 1. So epsilon will be equals to 1.5 over 0.5. So it will be equals to 3. So the correct answer is epsilon equals to 3. So the value of dielectric constant for water is 3. Now next question 55. The radius of a nucleus of mass number 64 is 4.8 Fermi. Then the mass number of another nucleus having radius of 4 Fermi is given by this. We have to find the value of x. So this question is from the chapter of atomic and nuclei physics. Atomic and nuclei physics. Okay. Now, we are given with the mass number and radius of one nucleus, and we have to find the this value of x, and this whole is the mass number of second nucleus. Let us say the first nucleus is A1 and the second nucleus is, let us say, A2. Okay. And we know that the relation between radius and the mass number for a nucleus is given as R equals to R naught A to the power 1 by 3, where A is the mass number, R is the radius, and R naught is a constant whose value is given as 1.5 Fermi, means 1.5 into 10 to the power minus 15 meter. 1 Fermi is equals to 10 to the power minus 15 meter. Okay. Now coming back to question for nucleus A1. This R is given as 4.8 Fermi equals to R naught into A1 power 1 by 3. For A2 it will be 4 Fermi equals to R naught into A2 power 1 by 3. Okay. Now taking cube of both the side in equation 1 and equation 2 and dividing equation 1 and 2, we get 4.8 over 4 whole cube will be equals to A1 over A2. Okay. Now A1 is what? 64 and A2 is 1000 by x. So it will be equals to 4.8 over 4 whole cube. It is equals to 64 over 1000 by x. Okay. Now it will be equals to 4 ones are 4, 4 twos are 8. 1.2 whole cube will be equals to 64 over 1000 by x. So it will be equals to 1.2 whole cube, means 1.44 into 1.2. It will be equals to 64 into x over 1000. So now x will be equals to 1.44 into 1.2 into 1000 over 64. So we get the value of x is 27. So the mass number of the second nucleus is 1000 over x, where x value is 27. Okay. Now next question 56. The identical squares each of mass 2m are placed at the corners of a right angle triangle with mutually perpendicular sides equal to 4 meter each. Taking point of intersection of these sides, two sides as origin, the magnitude of position vector of the center of mass of the system is 4 root 2 over x, where the value of x is. Okay, so we have to find the value of x. So this question is from the chapter of rotational motion. Rotational motion. Okay. Now according to question, there is a right angle triangle. Okay. Right angle triangle, and it is having the corners having 2m mass, 2m, 2m and 2m, and this will be considered as the origin, and the side is of 4 meter. Okay. Taking point of intersection as the origin, the magnitude of the position vector. Okay. So position vector magnitude will be, this is very simple question. Just apply the formula. It's R center of mass, COM. Its formula, we all know its formula, M1R1 plus M2R2 plus M3R3 over M1 plus M2 plus M3. So it will be equals to M1 into R1. 2 1 into its coordinate are 0 0. So 2M into 0 plus M2 into R2. 2M and its coordinates are what? 4I comma 0 means 2M into 4I plus M3. Its coordinates are 0 comma 4 4j cap means it is in y direction na. So 2m into 4j cap over 2 plus 2 plus 2 means 6. So position vector r will be equals to 4 into 2 6 iota cap. No, sorry, 4 2 into 8 iota cap plus 8 j cap over 6. So r will be equals to 4 over 3 iota cap plus 4 over 3 j cap. Now, taking its magnitude, to we get r equals to under root of 4 by 3 whole square plus 4 by 3 whole square. So, it will be equals to under root of 16 over 9 plus 16 over 9 means under root of 32 over 9. So, r will be equals to 4 root 2 over 3. Now comparing it with the given equation in the question, 4 root 2 over x. 4 root 2 over x means here the value of x is 3. This is our final answer. Now next question 57. A tuning fork resonates with a sonometer wire of length 1 meter stretched with a tension of 6 Newton. When the tension in the wire is changed to 54 Newton, the same tuning fork produces 12 beats per second with it. The frequency of the tuning fork is okay. So this question is from the chapter of oscillations and waves. Oscillations and waves, okay. So we have to find the frequency of the tuning fork, okay. At first, when the length is 1 meter, the tension is 6 Newton. And in the second case, the length is same and the tension is changed to 54 Newton and the tuning fork produces 12 beats per second. Beats means number of maximas heard in 1 second. Number of maximas heard in 1 second. Okay. So the formula for frequency f is equals to 1 over 2L under root T over mu. Okay. So according to question F1 is equals to 1 over 2. Length is 1 meter. Under root T. Tension is given as 6 Newton over mu. This is first. And for second case, F2 will be equals to 1 over 2 into 1 into 54 over mu. This is second case. Now, according to question, there are 12 beats per second, means F2 minus F1 equals to 12. So solving it, we get 1 over 2 under root 54 over mu minus 1 over 2 under root 6 over mu is equals to 12. So taking 1 over 2 common, under root of 54 over mu minus under root of 6 over mu is equals to 12, and under root of 15 or 54 over mu means under root of 54 over mu means 54. 2 2s are 4, 1 5, 2 7s are 14, 3 9s are 27, 3 3s are 9, 3 1s are 3 means 3 root 6. So it will be equals to 1 by 2, 3 under root 6 over mu minus under root 6 over mu. It will be equals to 12. So it will be equals to 1 by 2 into 2 root 6 over mu equals to 12. Okay, so 2 cancel. So root 6 over mu means 12. Now putting this value of root 6 over mu equals to 12 in equation first and solving it, we get f1 equals to, now solving it by putting the value, we get f1 is equals to 1 over 2 into 12. So 2, 6 are 12. So f1 will be equals to 6 hertz. So our correct answer is f1 equals to 6 hertz. Now next question 58. A plane is in level flight at constant speed and each of its two wings has an area of 40 meter square. If the speed of the air is 180 kilometer per hour over the lower wing surface and 252 kilometer per hour over the upper wing surface, the mass of the plane is. Okay. Now this question is from the chapter of properties of solids and liquid. Now we are given that the speed of the air is 180 kilometer per hour over the lower wing surface. Means V2 is equals to 180 kilometer per hour according to question, and V1 is equals to 250 kilometer per hour in upper wing. Okay, and now for solving this question, we will use what? We will use Bernoulli's equation, okay, for solving such type of question. The Bernoulli's equation is what? P1 plus 1 by 2 rho V1 square equals to P2 plus 1 by 2 rho V2 square. Since V1 is greater than V2, V1 is greater means this pressure is lower, and V2 is less means pressure P2 is greater. Okay. Now, using Bernoulli's theorem, we write this P1 plus half rho V1 square equals to P2 plus half rho V2 square. Now, putting the values. So, P1 pressure, P1 is given as what? Now, writing it as P1 only equals to 1 by 2 rho into V1 square. V1 square means 4900 minus, taking it here, it will be 2500 equals to P2. Now taking P1 from LHS to RHS, we write 1 by 2 into rho into 4900 minus 2500 equals to P2 minus P1. Okay. Now this P1 is the pressure that is acting from the upward direction over the wing, and P2 is the pressure that is acting from the downward direction on the wing. Okay, and mg is acting in the downward direction. So for this, the mg downward force will be equals to what? Area of the wing into this P2 minus P1. So in place of this P2 minus P1, we can write P2 minus P1 is equals to mg over A. Okay, so this half into rho into 4900 minus 2500, it will be equals to mg over A. This density rho is 1, so we write 1 by 2 into 1 into 2400, it will be equals to m into gravity 10 over A. Area, this area will be 40 meter square, means upper and lower. So 40 plus 40 means 80. So it will be equals to, area will be 80. So solving it, we get m is equals to 1 by 2 into 2400 into 80 over 10. 12000 cancel. So m will be equals to 9600 kg. This is our final answer. So the next question is 59. The current in a conductor is expressed as I equals to 3t square plus 4t cube, where I is in ampere and t is in second, the amount of electric charge from t equals to 1 second to t equals to 2 second is. Okay. So this question is from the chapter of current electricity. Current electricity. So we are given the current as I equals to 3t square plus 4t cube. We are asked to find the electric charge that flows through the section of the conductor. Okay. So dq is equals to I dt. So q is equals to integration from t equals to 1 to t equals to 2 second I dt. So it will be equals to 1 to 2 3t square plus 4t cube dt. So it is equals to 3t cube by 3 plus 4t 4 by 4 from 1 to 2. 4, 4, 3, 3 cancel, and putting the limits we get 2 cube minus 1 cube plus 2 power 4 minus 1 raised to the power 4. So it will be equals to 8 minus 1 plus 2 to the 4 to the 8 was 16 minus 1. So it will be equals to 7 plus 15. So Q will be 22 coulomb. So the value of charge is 22 coulomb. Now next question 60. A particle is moving in one dimensional along x-axis under the action of a variable force. Its initial position was 16 meter right of origin. The variation of its position with time is given as x equals to minus 3tq plus 18t square plus 16t. Okay. We have to find the velocity when its acceleration becomes 0. So this question is from the chapter of kinematics. We have to find the velocity when acceleration is 0. Okay. We are given x equals to minus 3t cube plus 18t square plus 16t. We know that velocity v equals to dx over dt. So v will be equals to minus 9t square plus 36t plus 16. Okay. And now acceleration is equals to del v over del t. So A will be equals to minus 18t plus 36. And we have to find velocity when acceleration is 0. So putting A equals to 0, we get minus 18t equals to minus of 36, minus minus cancel. So t equals to 2 second means the acceleration becomes, when the acceleration becomes 0, the time is 2 second. So putting this value of 2 in the velocity part, so we get velocity v for time equals to 2 second equals to minus 9, 4 plus 36 into 2 plus 16. So velocity v will be 52 meter per second when the acceleration becomes 0. So this is our final answer.